Hi everyone! In this video, we will solve a rational equation that results in a linear equation. Solve negative 5 divided by 6x minus 1 divided by 3x equals negative 1/2. The first thing we want to do is find the lowest common denominator between all three of these denominators. If we find that, we can actually get rid of all the fractions, which makes it a much easier equation to work with. The lowest common denominator needs to be the number that both 3, 6, 2, and x will all divide into. And so if we find 6x, this is the lowest common denominator. All three of those will go into that number, and it's the smallest number that they'll all go into. So now that we have the lowest common denominator, we will multiply the entire fraction by the lowest common denominator. This means that I need to multiply it with the distributive property, so we will multiply it to every single term. So we get 6x times the negative 5 over 6x, and then we'll times the second term, 6x times the 1 over 3x, and 6x times the 1/2 6x. I'll do it on that side. Okay, on the first one, 6x divided by 6x cancels out. And so now we only have a negative 5. And you'll see that we end up getting rid of all of the fractions that way, and it's so nice. On the next one, the next term, 6x divided by 3x, the x's will cancel, and 6 divided by 3 is a positive 2. So we have minus 2 times the 1. 2 times 1 is 2, so it's just minus 2. Now on the right-hand side, we'll multiply the 6x times the negative 1/2, and we can go ahead and simplify this as well. 6 divided by 2 is 3, and the x didn't cancel on this one. So we have negative 1 times 3 times x that are all left, and negative times positive is negative, so we get negative 3 and x. Now we can go ahead and finish solving by subtracting on the left-hand side. Negative 5 minus 2 is negative 7 equals negative 3x. Then we continue solving by dividing both sides by negative 3. A negative divided by a negative is positive, so we get 7 over 3. Negative 3 divided by negative 3 cancels, and so we get x equals 7/3. And we're all done.